Hi, my name is Roshan Sharma and I'm from Carnegie Mellon University. Today I want to talk about our recent work, ESPNet-SUMM, introducing a novel large dataset, toolkit, and a cross-corpora evaluation of speech summarization systems. This is work done with collaborators from Carnegie Mellon, NTT Japan, the University of Massachusetts Amherst, and Mohammed bin Zayed University of AI in Abu Dhabi. First, I will briefly introduce the task of speech summarization and the motivation behind our work. Then, I want to describe the new dataset that we are making available, the interview dataset. After that, I will describe our benchmark comprising end to end and cascade models and provide inputs on when end to end models might be more suitable than cascades. Next, I will describe some of our initial work on transferring knowledge across corpora. Finally, I will describe the ESPNet-SUMM toolkit that we are making available and conclude with takeaways. Speech summarization is the task where we take in a very long audio sequence or speech frames and we want to predict as output a textual summary of the information represented within speech. So this is an example of a summary that you can expect. And the goal of speech summarization is to find the parameters theta that maximize the likelihood of the summary token sequence given the input audio and a set of learnable parameters theta. Summarization can be done using two approaches, end-to-end approach or the cascade approach. The cascade approach is a classical approach which has benefits in the form of interpretable and controllable intermediates. For example, the transcript in this case is interpretable and controllable. However, there are issues with cascade models, which include the effective model sizes and number of parameters scaling up. So, the total number of parameters of a cascade model would be the sum of its components, which is a very large value. Most importantly, cascade models suffer from error propagation effects. Any errors that are made in ASR propagate through the cascade, uh, causing severe harm to summarization. The advantage of cascade models is that the components can be trained independently and there is no need for paired data. End to end models, on the other hand, are not as interpretable as cascades but have small number of model parameters and end to end optimization mitigates error propagation effects. Since end to end models are jointly optimized, it requires paired speech summary data in order to train. In this paper, we make the following technical contributions. First, we address the dearth of labeled data for training and evaluating speech summarization models. There are very few data sets for monologue summarization, but no large scale open domain corpora for conversations. And therefore, we introduce interview, an open domain conversation summarization dataset with 4,354 hours of real speech. Next, we examine the two primary approaches, end to end and cascade models, and benchmark these approaches for four different summarization corpora and identify conditions when end to end models can outperform cascades. There are very few open source tools for speech summarization, and therefore we introduce ESPNet-SUMM, an open source toolkit that supports different encoders, at the moment, four summarization corpora and multiple metrics. Finally, when we have access to multiple corpora for speech summarization, knowledge can be shared to build stronger models, and we investigate transfer learning and multi style training to improve model performance. To address the challenge of dearth of labeled speech summarization data, we introduced the interview corpus. The interview corpus has about 49,000 recordings comprising 4,354 hours of real speech drawn from NPR radio interviews. We note that The interview corpus has a significant number of novel words, that is, words that are present in the summary which are not in the transcript, making it relatively challenging. On average, the audio recordings have a span of about 5 minutes and comprise 40 words on average. So, data can be obtained through the GitHub link posted below. Next, let's look at benchmarking of end to end and cascade models. So, we now have access to four corpora for speech summarization: how to, which is for video summarization; SLUTED, which is monologue TED Talk summarization; the interview corpus that we introduced for radio interview summarization; and the AMI meeting corpus. We built end to end and cascade models using ESPNet for the end to end model and Whisper plus T5 for the cascade models. We find that end to end models outperform cascades on the how to dataset and on interview, while they lag behind slightly for SLUTED and AMI. Based on this, we conclude that when the input length is short, smaller than 20 minutes, and when data is abundant, greater than or equal to 2000 hours, end to end models can outperform cascades. We do some ablation studies on end to end models to identify whether training them in the way they are currently trained has merits. First, we examine the importance of context in model training, and we find that as the length of the input context increases from 30 seconds, 60 seconds to 600 seconds, we see a significant improvement in RUGEL, which is the metric used to measure summarization performance. Therefore, more acoustic context improves summarization performance. Next, we investigate whether it is necessary to have two-stage training approaches where the first stage involves pre-training a model for ASR and then fine-tuning it for summarization. In order to do this, we compare a model that's initialized with a fully trained ASR, a partially trained ASR, and a model that's trained from scratch without ASR pre-training. Based on this, we note that ASR pre-training is important for summarization performance. Finally, we examine how to learn from other corpora. When multiple corpora are available for speech summarization, these corpora could be leveraged to aid performance on other corpora. In our case, we observed that SLUTED performed slightly worse with the end to end model when compared to the cascade, and therefore we investigate whether it's possible to improve performance on SLUTED using the interview data. We investigate two methods to use the interview data. The first is multi style training, where we combine interview and TED data within the training data. And the second is transfer fine tuning, where we first train the model on interview and then fine tune it on slew TED. We observe that though both of these approaches provide significant gains, multi style training very slightly outperforms transfer fine tuning. We hope that this finding can be used in future work to build speech summarization models that span multiple corpora. The ESPNet-SUMM toolkit is based on the ESPNet toolkit, which currently supports a variety of tasks including speech recognition, spoken language understanding, speech enhancement, and so on. ESPNet-SUMM builds on ESPNet to support more encoder architectures, including longformer and FNet, and has recipes for end-to-end and cascade models for abstractive speech summarization on four pub- publicly available datasets. ESPNet-SUMM also supports multiple metrics to evaluate summarization quality, including Rouge, BERT score, Meteor, and UniEval. In conclusion, in this paper, we introduced the interview corpus and the ESPNet-SUMM toolkit. We examined end-to-end versus cascade approaches for speech summarization and concluded that end-to-end models can outperform cascades when the input length is relatively small and when sufficient amount of label data is available. We also examined whether we could leverage available corpora to improve summarization performance on other corpora and found that transfer fine-tuning outperforms multi-style training. Thank you for listening. We hope to see you in Taipei. Please view our paper and attend the poster session. Please feel free to write with any questions to the email shown on the slide. Thank you.